Bismillahirrahmanirrahim. Sorry guys, I recorded the entire lecture and due to non-availability of internet, um, I have to record it again. It's okay, it's okay. Okay, now the new topic is benzene. Okay, if you remember benzene. So I have explained you in the start of this hydrocarbon that there are two types of hydrocarbons, aliphatic and aromatic. So aliphatic mein, I told you that there are three types, alkanes, alkenes and alkynes. And the second type was aromatic. Okay. So in the previous, in the past, it was mentioned that any structure having benzene ring, so they called it aromatic. But with the passage of time, this idea was discarded, and then another idea was given, which is related to Huckel's rule. And when I'll explain to you the Huckel rule, only then you can understand that what I actually meant. Now, benzene is the simplest member of aromatic compounds. And if we go to the introduction of the benzene, so its name is benzene, its molecular formula is C6H6, and the structure is the cyclic planar. Hybridization is sp2, bond angles 120, and bond length is 1.39, which is an intermediate of single bond length and double bond length. Next, we go to the slide third, in which it is written that benzene is a colorless compound with melting point of 6 degrees centigrade and boiling point of 80 degrees centigrade. It was first isolated by Michael Faraday in 1825 from the oily residue collected in the illuminating gas lines of London. Benzene's molecular formula is C6H6, and the formula suggests a high degree of unsaturation. So compared with the corresponding alkane of molecular formula C6H14. So now benzene, the molecular formula of benzene is C6H6, okay? So if 6 carbons are there, then there must be 14 carbons. So if 14 carbons are not there, only 6, if 14 hydrogens are not there and only 6 hydrogens are there, it means that the index of hydrogen deficiency in benzene is 4. Okay, so now the benzene's index of hydrogen deficiency can be met by an appropriate combination. So now we can think that if there is the index of hydrogen deficiency is 4, then it must be having rings, double bonds and triple bonds. For example, C6H6 molecular formula might have 4 double bonds or 3 double bonds and 1 ring, or 2 double bonds and 2 rings, or 1 triple bond and 2 rings, and so on. So considering benzene's high degree of unsaturation, it might be expected to show many of the reactions which are the characteristics of alkenes and alkynes. So alkenes, alkenes and alkynes, they readily undergo addition reactions. Now, why alkenes and alkynes are very reactive? Because of the presence of the double bond and the triple bond. Double bond means that the surplus availability of electrons, which can be easily grabbed or trapped by any electrophile, thus to make the new bond. But in the case of benzene, it is highly unreactive. It does not undergo addition reactions. Now, moreover to addition reactions, it does not undergo any kind of reactions like oxidation reactions, reduction reactions, and these oxidation reactions, reduction reactions, additions reactions, these are the characteristics of double bonds and triple bonds. Now, for example, benzene does not react with bromine, hydrogen bromide, or other reagents that usually add to carbon-carbon double bond and triple bond, right? Neither it is oxidized by chromic acid under conditions, तो ना ही ये कोई और reactions है इसमें. और अगर if we compare the attitude of benzene with the alkenes and alkynes, So alkenes and alkynes, they greatly undergo addition reaction, oxidation reaction, and reduction reactions. Next, we go to slide 7. Now, the term aromatic was originally used to classify benzene and its derivatives because of many of them have distinct orders. In the past, it was believed that anything having benzene in the structure is aromatic. Okay, so aromatic is the word which is it was considered in the past that anything which is having aroma must have been the benzene structure. Okay, so that's why they are known as aromatics. Now the term aromatic is now be used as highly unsaturated and unexpectedly stable towards reagents that attack alkenes and alkynes. So हम अब जो है aromatic को use करते हैं for highly unsaturated and stable compounds. इसके अलावा आपको पता होगा कि हम जो हाइड्रोकार्बन्स हैं आपके सिंगल बॉन्ड वाले, वी कॉल देम एल्केन, डबल बॉन्ड एल्कीन, ट्रिपल बॉन्ड एल्काइंस. इसी तरह बेंजीन जो है वो पेरेंट है और हमने इसको नाम दिया है एरीन का. ओके, सो दिस इज एरीन and it is analog to alkane, alkenes and alkynes. So aliphatic hydrocarbons में alkane, alkene and alkyne, in aromatics it's the arene. Just as the अच्छा, अब इसमें इस slide number 8 में it is explained over here that just if when we remove one hydrogen from CH4, which is the first member of hydrocarbon, methane, if you remove one hydrogen, the methane is converted into methyl group. Now this methyl group can be substituted on the parent chain. ठीक है, पेरेंट चेन में हम methyl group को भी कर सकते हैं, ethyl group को भी कर सकते हैं. What's the difference? Difference is that the one hydrogen is less. Similarly, if we remove one hydrogen from benzene, it is then converted into a group which is called aryl group and the symbol is AR. For alkanes, methyl हो गया, ethyl हो गया, proper हो गया, इनके लिए हम use करते हैं capital R. R is the word which is used for the alkyl groups. So AR is used for the aryl groups. Next, the structure of benzene, KEKULES model of benzene. Achha, the first structure of benzene was proposed by August KEKULE in 1865 and consisted of a 6-membered ring with one hydrogen bonded to each carbon. अब 6-membered ring है, okay. इसमें 3 डबल बॉन्ड्स हैं और हर कार्बन के साथ एक हाइड्रोजन भी है. सो टोटल 6 हाइड्रोजन्स हैं और 6 कार्बन्स हैं. सो ऑल्दो KEKULES ओरिजिनल structure formula provided for the equivalency of CH and CC bonds, it was inadequate because all the carbon atoms were trivalent. Now this needs to be explained very carefully. Now, to maintain the tetravalence of carbon, KEKULE proposed in 1872. अब जो हमने अब तक explanations दी थी to justify the structure of benzene, उसमें कार्बन की कार्बन doesn't show tetravalency, तो उसको maintain करने के लिए to justify the or to maintain the tetravalency of carbon, KEKULE ने proposed किया था कि in 1872 में that the ring contains 3 double bonds that shift back and forth. यानी कि एक उसने structure draw किया 6-membered, उसमें the position of the double bond, then he drew the second structure और उसमें जो position of the double bond वो different थी. जो पहले structure में single bonds थे, in the second structure they were shown as a double bonds. ओके, सो इससे क्या हम कंक्लूड करते हैं कि ये जो आपका पाई सिस्टम है इसमें ये डीलोकलाइज था, इट वाज नॉट लोकलाइज्ड, और ये इलेक्ट्रॉन्स जो थे ये मूविंग थे, स्टैटिक नहीं थे. ओके, सो और जो 2 स्ट्रक्चर्स हैं वो दोनों इक्विलिब्रियम स्टेट में हैं और इनको सेपरेट करना इज हाईली difficult. So KEKULE regarded this interconversion as an equilibrium. Each structure in which has become known as KEKULE structure. Now we come to structure number slide number 11. Now here you can see the planar hexagonal structure of benzene. Okay, now this structure is planar, hexagonal structure है. All the CC bond angles are 120. Each carbon is sp2 hybridized and p orbitals perpendicular to the 6-membered ring. अब बॉन्डिंग होती कैसे है इसमें, ये आप अंडरस्टैंड कर लें कि दीज आर द 6 कार्बन. ओके, कार्बन नंबर 1 2 3 4 5 एंड 6. सो sp2 hybridized, इट मींस कि वन ऑफ द p ऑर्बिटल जो है उसने पार्टिसिपेशन नहीं की हाइब्रिडाइजेशन में, दैट्स व्हाई इट इज sp2 hybridized. ओके, सो दैट p ऑर्बिटल रिमेन परपेंडिकुलर टू द कार्बन्स, and these p orbitals then by sideways they overlap with one another. Okay, so ye overlapping karenge, these two overlap to give one double bond over here, these two overlap to give one double bond over here, and these two overlap with and one double bond here. इधर ही अब आपको दूसरा स्ट्रक्चर भी मैं जस्टिफाई करती हूँ so that you can easily understand कि why two structures are written for benzene structure. So मैंने ये लेफ्ट से ओवरलैपिंग स्टार्ट की है. अगर मैं यूं सामने से ओवरलैपिंग स्टार्ट करूं, सो इफ दीज टू ओवरलैप, तो पहला आपका डबल बॉन्ड इधर होगा, ये दो ओवरलैप करेंगे और ये दो ओवरलैप करेंगे. इस तरह आपके पास टू स्ट्रक्चर्स आते हैं. सो नाउ द क्वेश्चन इज के व्हाई there are two possibilities. Just because of this, that the pi system is not localized, it is the delocalized system. So each carbon forms sigma bonds to two adjacent carbons by overlap of sp2 sp2. इसका मतलब ये है कि let's see this diagram कि ये कार्बन और ये कार्बन जो है ये ओवरलैप करेंगे by using the sp2 hybridization. Okay, नेक्स्ट इसमें ये है कि और बने, और इसमें क्या होगा कि एक इसका सिग्मा बॉन्ड, दिस कार्बन मेक्स वन सिग्मा बॉन्ड हियर, ये कार्बन एक सिग्मा बॉन्ड बनाएगी हाइड्रोजन के साथ इस तरफ, एंड द सेकंड कार्बन मेक वन सिग्मा बॉन्ड विद हाइड्रोजन. ओके, नेक्स्ट वी कम टू दिस के ऑल कार्बन कार्बन बॉन्ड्स आर 1.39 in length, a value almost midway between the length of a single bond between sp3 hybridized carbons जिसका के 1.54 है, and double bond sp2 hybridization जिसकी 1.33 है. So जितने भी जो bond lengths हैं बेंजीन के अंदर, they are the average of single bond length and double bond length. So that's why in one structure, if double bond is there, in the second structure it is converted into single bond. So that's why these double bonds and single bonds really